Welcome back, Hyperbolic Coding Chamber participants. This is day 34, LeetCode every day. Reflections on the last few days. Things have been going swell. Progress is being made, revision is being done. However, I'm still blocked on a couple problems. We have longest substring I've been blocked on, longest palindrome I've been blocked on, and O1 matrix I've been blocked on. I wanted to get through O1 matrix before going to these other three, but these are the same problems that we're going to be working on today. Hopefully we can break through them. I've done them, read the solution, done them, read the solution. I still don't get it. This might be the one. I think I'm starting to intuit why my original solution didn't work. And yeah, and then also we also do longest palindrome, longest substring. An hour and 30 minutes on the clock as usual, but the hour and 30 minutes as usual. But to be honest, I think these three problems will be more than enough to take up the time. So we'll do O1 matrix. Hopefully we can solve that one. I sincerely doubt it, but you know, for the sake of this one, I'm going to definitely cap my try at 30 minutes. Just have to make progress on other problems. So we'll do 30 minutes of that one, 30 minutes of longest palindrome, 30 minutes of longest substring, and then maybe we'll be in good shape. We'll see. That being said, 34 days of LeetCode so far. I mean, not many of there's not been a consistent time length on all the practice sessions. The goal is 1 hour and 30, but that has varied. But it's been mostly, I think for the most part, since we switched to 1 hour 30, it has been 1 hour 30. But that is besides the point. Yeah, make sure to join the Hyperbolic Coding Chamber Discord. It's pretty hype in there, and you know, pretty simple. Just jumping in to another day of the grind. So day 34 of LeetCode every day, starting with O1 matrix. So too big. So given an M by N binary matrix mat, return the distance of the nearest zero for each cell. So we need to return the distance of the nearest zero for each cell. Distance between two adjacent cells is 1. Distance between two adjacent cells is 1. So this is our example matrix for this binary matrix mat. We're going to return the distance of the nearest zero for each cell. So that since this cell is 0, the nearest zero for the cell is itself, so on and so forth until we get to 1, where the nearest zero in any direction basically is, yeah, so this would be the minimum distance. Any of these ones would be the nearest distance. So the output is a new matrix, but with that one having stayed the same. And so for this one stays the same, this one stays the same, but the output is actually 2 for this one, because the nearest one is actually this 0 or this 0 here, which is 2. So some clarifying questions. The matrix length is M, and for a particular matrix of I, the value is going to be N, which means that our matrix is going to be somewhat uniform. So we can't have 2 rows and 3 columns. I mean 2 columns and 3 columns and 3 columns. And both M and N are guaranteed to be at least 1. So we know we'll have at least 1 row, 1 column. And I sub j is either 0 or 1. There's at least 1 0 in mat. So I would say the first thing we could try, since we haven't been able to succeed at this problem, would be a brute force solution first. So in this one, we could just do exactly what the problem is calling for. Iterate over the entire binary matrix, and then for each cell, iterate over matrix for matrix, right? And for each cell, right, what we're going to do is find the nearest zero, right, by iterating over the entire matrix. So this time complexity would be a little crazy, but I think we should be able to get a proper solution with it. One thing to consider though is if we should modify the matrix itself or copy it and then make modifications to it. Let's consider the first case where we don't copy it. If we don't copy it, then, for example, this solution doesn't really change much if we don't copy it. But let's just say this one, what would change? Changes to 2. Maybe that's fine because what we're looking for is 0. So if this is 1, 3, 4, 5, 6, it's irrelevant because it's non-zero. So let's not copy it. We'll brute force iterate over the matrix. Way to iterate over a matrix is to do rows and columns. So we'll say rows equals 0, rows is less, or say row equals 0, row is less than mat.length, row plus plus. Right, then we want to iterate over the column, so we'll say let call equals 0. Right, call is less than mat sub row dot length, call plus plus. And then, right, so for each cell, right, we want to do another inner double for loop, right? And so the cell that we're going to be interested in is going to be row comma call. And so we can actually probably duplicate these two lines, move them forward, and then the goal here will actually be to just do, we'll just call this R2 and C2, right? While R2 is less than math.length, we'll do R2 plus plus, and then instead of call, we'll do C2 and mat sub R2, right? And then we'll say C2 plus plus. So I want to iterate over the entire matrix for this one cell, and we're going to say that the nearest 0 equals, we're going to be taking the min, so we're going to set this equal to infinity, right? And nearest 0 is going to get the math.min of the way we're going to calculate the distance. So it will be, so if we add this one here, that would be 2, 1 with 0, 1. So we'd have 2, 1, right, as our 1 location, and 0, 0 as our 0 location. So the distance there would be the absolute value of the x's minus the y's distance here is 2. So if we do x minus 2, 0 minus 2, we get negative 2 absolute value is 2, and then 0 minus 1 gives us negative 1. And if we add those, we get a distance of 3, so it's not exactly what we're looking for. So it's got to be in a better way. Oh, this is not 0, 0. This is 1, 0. So we'd have 2 minus 1, right, gives us 1, and 1, no, this is not 1, 0, yeah, it's 1, 0, and this would be 2, 0, 1, 2, 1. So we have 2 minus 1, 1 minus 0, 1 minus 0 would be 1 minus 0 would be 1. So we have 1 plus 1. The distance there would be 2. So that does actually work. So we could do that. So it would be nearest 0. And we created distance, right, which would just calculate distance between R2 and C2 and basically row and column. So I'm going to do the math.absolute value of row minus R2 plus the math.absolute value of col minus C2 and D. And then at the end of this, we would say mat sub row sub col equals nearest 0, and then we could return mat. So that's what a brute force solution would look like. So for example, if we take this one here, its row is going to be 0, 1, 2. So it's going to have row 2 and col 1, right? So it's going to have row equals 2, col equals 1. Then we're going to have R2, right? Let's just say we're at this 0 up here, right? This is going to be 0 and 1, right? So row 0, index 1. And so the way we calculate our absolute value is going to be row minus R2. So move this up here, we'll say 2 minus 0 is 2, and 1 minus 1 is 0, so the absolute value is 2, so the distance would be 2. So that seems to check out, at least in the short term, so let's see what we get. So our output is all zeros. So for this 1 here, right, we start with 1, 1, right? And let's just say we start with this 1 up 0 up here. We have 0, 0. So 1 minus 0 would be 0. R2 would be 1. So 1 minus 0 would be 1. And 1 minus 0 again would be 1. And if we add those two together, so we're not even getting we're getting 0. So maybe we want to skip our own value, because if we subtract from ourself, then so we'll say if col does not equal C2 and R2 does not equal row not equal R2, then we want to do this work in here, and then even then nearest 0 will be the math.min of nearest 0, and the original value for the we don't have to do the original value. So let's see. So now it's 2 for everyone so we said if call, so we basically don't want to, we want to ignore our current, just that current indice, right? So the cell we're working with is call sub row. We don't, when we're iterating in the entire matrix, we want to ignore the one we're currently at. The one we're currently at is row and call. So if we have call does not equal C2 and row does not equal R2, then we should be able to calculate what we need to calculate. But we're getting the wrong answer, which means we don't understand exactly what we're solving. Let's remove the code we added, and we get all zeros. So why are we getting all zeros? So let's just say for a particular row and column, 1, 1, right? So we're at 1, comma 1, right? We're getting 0 somehow. So if we run this so far, if we run this for 0, let's check the distance. The distance, so we have 1, 1, right? 1 minus 0 is 1, and 1 minus 0 is 1. So our distance is 2, which makes sense. 1, 2, right? Then we get up here, we have 0, 1. So 1 minus 0 is 1, 1 minus 1 is 1. And so now I have 0, 2, so 1 minus 0 is 1, but 2 minus 1 is 1, and the addition of that is 2. Then we get to 1, 0, 1 minus 1 is 0, but 1 minus 0 is 1. Then we get to our cells, we get 1 minus 1, which is 0. So it seems to be actually hitting ourselves, which is actually giving us this 0 value in the center. So we tried to avoid ourselves before, and the way that we did that did not produce the correct answer. So maybe what we could do is we could say maybe if, and I'm going to quickly change row from R1, change row from row to R1. This is kind of messing me up a little bit. And then we'll change call to C1. We'll change row to R1. And so here we can say if R1 equals R2 and C1 equals C2, all right, then we just want to continue and not do the work for this iteration. So when we get to 1, 1 here, which would be our cells, we would continue and not do the subtraction of it, which would give us 0. So now we get now we get 1, but when our value is actually 0, it creates an issue. So maybe what we additionally want is to take, I think I see, if the value is a non-zero value, right, then we'd only, when we want to ignore it, then if the rows are the same, right? But at the same time, we could also just do the math. We could also just include the math.min of nearest 0 and the original value itself. So let's see if this takes us to the promised land. So we do get a wrong answer. So that is interesting. Right, and this is what I was worried about. So the one we're getting is the value itself, but doesn't necessarily say that that value is actually something we should consider, because a 1 is just a 1 here. All right, we want to find the nearest 0, and the current value in the cell has no bearing on that. So that being said, though, I think the best thing we want to do is if mat sub r1 sub c1 is greater than 1, is greater than 0, and we're at our particular indices, then we want to ignore it. So interesting, you want to ignore it. Oh, the nearest 0, not the nearest cell. So this is another issue. I think I'm realizing the problem. We want to find the nearest 0. We never even considered the nearest 0. I'm going to say if mat sub r2 sub c2 equals 0, then we want to do our work. The problem is that we're still doing work on indices that we're calculating the distance between all indices, basically. So now I think it's actually working. Now it's actually working because we're running out of time. So this is the brute force solution. And so is there any way we can optimize the brute force? Is there a way we could optimize it? So we're always, or reuse our answers. Each time we get to a cell, we're revisiting the closest 0 for that cell. Or revisiting, or recalculating the distances to the cell. So what if the nearest cell could hold the value of its nearest 0? So if we know that the nearest 0 to this one is 2, or unless you say another cell down here, then we know that if this one's nearest distance is 2, then I just have to add 1 to the closest non-zero next to me. That would be the maybe that could be an optimized version. We could say mat r2 sub c2 equals 0. Then if it equals 0, which is our inner loop, right? And so for every cell we're doing this, maybe we only want to do this 4 cells. Maybe this is a slight optimization again. Maybe we only want to do this 4 cells that are non-zero. You could say R1 sub C1 does not equal 0, right? And this whole thing would go inside. Maybe we would take even less time, right? So we'd be skipping all 0 values. additionally, the worst case would just be that the entire array, oh, so this semi works. The worst case that we could have would be that the entirety of the matrix is ones. Yeah, the entirety of the matrix is ones, and there's only 1 0, which is in the bottom right corner. And so we do every single operation. We do every single operation, which would not work very well. 6 minutes. Could read the solution. Is that good enough? We could read the solution. Is brute force enough? We could read the solution. So that is one way to do it. And then from there, maybe another way you could do it. From there, maybe another way you could do it, I'm thinking it could be something done with a depth first search. If we do it with a depth first search, to carry this cascading values, we could check pretty much all around a particular cell and see if there's already a non-zero value there. If there is already a non-zero value there, but the problem is we could just add 1 to that non-zero value, or the smallest one. I think the problem there is that, do we know that the array is pre-set up to already accommodate us, or are these random values? So like this is 1 1 1 1. So if these are 1 1 1 1, it kind of seems like we could just look over here, or look over here and add 1 to it, right? But we don't know if these values given to us are actually validated in the sense that they already are pre-filled to have value of the nearest 0. If not, then what we could do is fill it up, all the non-zero values, with one identifier, would be something like infinity. And then from there, if we could calculate the value for a 1, and then we go to the next indice, we could just take the closest value that's non-int max, which would be this one here, but it's possible that the closest distance well, actually, it doesn't matter, because even if there were the things, the closest distance to 1 can't be better than right next to us. But initially, if this wasn't a 1, maybe this was a 3, we'd add 1 for it. Maybe our closest 1 is actually right here. So the best order to maybe do this in were to go down the center, perhaps. We still end up with the left-hand side having potentially better distances. So I think the best, even if you did level by level, well, you still wouldn't know if your better distance is below you. So let's see what the solution has to say. Brute force, time to exceed it. Do exactly what the question asks us to do. For each cell, find the distance of the closest 0. Initialize dis sub I sub j equals int max for all ij cells. Iterate over the matrix if cell is 0. If the cell is 0, dis I sub j equals 0. Otherwise, for each one cell, iterate over the entire matrix. If the cell is 0, calculate its distance from the current cell, which is absolute of k minus 1 plus L minus j, which makes sense. If the distance is smaller than the current distance, update it. So it looks like they're creating a new matrix here. That's why they're doing it this way. So that makes sense. But they're also taking the min, saying if matrix. So this part is so that they can copy the zeros. Else iterate over all the rows and columns again. If it's a 0, right, then you want to calculate the distance to our current cell. That's what we have currently. It's RC squared So iterating over the entire matrix for each one in the matrix. Constant space other than the space required to store the output. So a better brute force is looking over the entire matrix. Over the entire matrix appears wasteful. Hence we can use breadth first search to limit the search to the nearest zero found for each one. We can use the breadth first search to limit the search to the nearest zero found for each one. As soon as a zero appears during the breadth first search, we know that the zero is the closest, and so we move to the next one. But in this approach, we only be able to update the distance of 1, 1 using 1 BFS, which could in fact result in slightly higher complexity than the brute force approach. Interesting. Interesting. So I think we'll take that as a brute force pass, but we'll still need to keep working on it so that we can do better than brute force. But we will take that. So now we still have another hour, so let's try longest palindrome. So we're given a string S, which consists of lowercase or uppercase letters. You have to return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, AA is not considered a palindrome here. So we're given a string S, which consists of lowercase or uppercase letters. Looks like an S, this only includes lowercase letters. We can return the length of the longest palindrome that can be built with those letters. So our output is 7. But one of the longest palindromes that can be built is DCCA-CCD, whose length is 7, but the overall length of the string is actually 8. So I think one method you could use to solve this, just brute force, take a lot of time and space, is generate all permutations of the string as well. So for each, so we have a string, right? Given characters, we'll generate all permutations of it, then subtract a character, generate all permutations of it, then subtract a character, so on. Basically generate all combinations of the string, and then run this palindrome function, which could be done in linear time with constant space. And then we would just take the minimum of the iteration over all of those strings. But for this version, generating all those permutations would take a very long time. So we have A, the longest palindrome that can be built is A, whose length is 1. And the s.length always has at least one character, and it only consists of lowercase or uppercase letters only. So that being the case, we could take more of a structural approach. Instead of generating all possible permutations, we know that structurally a palindrome is a string that can be is the same forwards as it is backwards. Structurally, that requires at max one letter be odd, because it has to fit in the middle, or no odd letters, but all even number of letters, right? So you can have 500,000 A's and 1 B, and you could have 250,000 A's on the left hand, 250K A's on the right hand. The B would go in the center. You could also have just those 500,000 A's, right? But just infinitely, that would still be the same forwards as it is backwards. And you could have a ridiculous number of A, B, C, D, but as long as we have an even number of both, then we can always match parity, right? So that you need a pair to be able to read forwards and backwards. So I think structurally, we could probably create a solution based off of the contents of the map. So this map would look like A equals 1, B equals 1, C equals 4, and D equals 2. And so if we were to load these into a map, is what we'd have, right? And so we want to output 7, which is the longest palindrome we can create. If we look at it, we see that we have 4 pairs of C's. We have 2 pairs of C's, which is 4 total characters, 1 pair of D's, which is 6 total characters, and we can either choose 1 odd character remaining, right? So if we do that, so if that's what we're doing, then I think one way we could go about solving it is to simply keep, if we have for example, we have C here, right? If we have for pretty much every letter or character in the map, right, we could divide, the number by 2, right? And if it's still divisible by 2, then we could add the half of that to the length of our string. So what I mean by that is if we do C, right, which is 4 occurrences divided by 2, right, which gives us 2, right? But 2 mod 2 gives us 0, so we could add 4 divided by 2 to our length, so we have 2 so far, right? Then we could do it again for C, right? We'd say 2 divided by 2 equals 0, right? And 0 mod 2 gives us 0 mod 2 so 0 mod 2 would give us 0, which would be perfect, because then we could add so it might be a little different because we have 2 divided by 2 would actually give us 1. So maybe the way we want to do it is multiply 2 by how many numbers we get, but this would still give us now a length of 4, right? Then we could go to D. 2 divided by 2 gives us 1, right? And so since it gives us 1, we'll add 2 to our character, which would be 6, right? And then we can go to A or B, right? And so if A divided by 2 doesn't give us basically doesn't give us a whole number, and we can check that pretty much because A mod 2 does not equal 0. So since A mod 2 does not equal 0, right, then we'll add 1 to our length, and we don't have any more odds that we can consider, so maybe we'll have an odd flag. That being the case, how do we know when to stop? So once we have our odd flag, one way we could do this is we could just go until the map is empty, right? So if we go until, so say while map has elements, right? And so this is when we can stop. So the first thing we're going to need to implement this is a map, right, which is just going to be a map of string to numbers. And we're going to load that map by doing for const C of S. And we'll say const value, right, because if the map has the value, right, then we'll ask the map for the value, otherwise we'll return 0. And then we could do map.set C of value plus 1. Oh, and that should set the map equal to letters and occurrences. And then from here, right, we'll have a got odd flag, right, which means we already found one odd letter, right, to use, right? Once we find that odd letter, we can toss any one that is actually odd, right? So while map has elements, right? So we'll say while map.size. I don't know if it's a method or a function. I think it's a method or a property. I think it's a property. Is greater than 0, right? then we're going to want to iterate over the map, right? And so what it's going to look like is for const key current in map, right? Like we said, first you want to check if we can divide it by 2. So if we can do occurrence mod 2, right, equals 0, and we can divide it by 2 and get a value that we can use. And in the case, LSC doesn't have to equal 0, right? But basically, if we get 3, right, do 3 divided by 2. So we can actually just call this value. We'll do occurrence divided by 2, right? And the occurrence divided by, so we have 3, right? We divide it by 2, we get 1.5. We want to floor it. And we're going to want to return the length, right? Because that's what they want us to. The max length palindrome, right? And we have some other, just code, just characters we wrote. We have to remove that before we run it. And so we'd have 3 over 2 equals 1.5. So we'll floor it, right? We'll have a value of 1, right? So we actually want to set so we'll say if that value is, so it's already been divided by 2, right? So we'll have 1. And so basically, we said earlier we could divide it by 2, right? And so what we want to add to length would actually, we don't want to add it yet, right? So what is our exact case for when we want to add it? We divide it by 2, and the value is, this would be how many times 2 goes into the value. If the value is greater than or equal to 1, then we want to add it, right? So you'd say max plus equal 2 times value, right? So we had 3 characters divided by 2, we get 1, right? We want to add 2 of those characters to the max length, right? From there, we want to do map.setKey, right, to occurrence to the value, right? Because that's how many this character is remaining, right? So if we had a map like A equals 2, B equals 2, C equals 1, D equals 1, A equals 3, right? A max would now be 2, right? And A would be set to 1. Then we would go to B, right? And then B would be occurrence divided by 2, so that would be 1, and the value is greater than or equal to 1. So we'd add those 2 characters to max. That would be 4, and then we'd set B equal to value, which would technically be 1, but since there's no more pairs of it, right? Since there's no more pairs of it after this, so we'd have math.floor of occurrence over 2, right? There'd be no more pairs of it remaining in B, because we'd have done a 2 over 2, which is 1, and we've used a pair. So maybe what we want to do is set, actually get the value for the key, and we'll set it equal to the value, which it is, which is 2, right, minus 2 times value, right, which would set it equal to 0. Then we'll say if map.get key equals 0, and we do map.delete key. So then we would delete B, right? So we set it equal to 0, delete it, then we would go to C. So now we're in C, and right, we're going to do 1 divided by 2. That value is not going to be greater than or equal to 1, right? It's going to be less than that. But a value could still be odd, like 9, and it would go into it more than once. I think at the end of the day, when we do get this up, the case where we handle an odd number is at the end. So if this value is less than, what I mean by that is if we had 8, this would eventually become 4, then 2, and then from 2 it would get deleted. Oh no, it would become 5. So if we had 9, right? 2 goes into 9 4 times, so we get 8, and we get it to 1. Right? By the time we get to C again, we do divided by 2, we get 0.5. Since it's 0.5, we'd say else if right? And if not odd, maybe we'll just do it like this. We'll say if value is less than 1, right? And we haven't gotten an odd value yet, right? Then what we're going to want to do is do len plus equal 1, and then just delete the key. Else, right, then we're going to just want to delete the key. So if it's less than 1 and we already have odd, right, and we don't have odd yet, right, we're going to do length plus 1. So we should have, right, which is actually the best we can do. We change this to 5, right? And then we delete C, we'd go to D, right? Is 1 divided by 2 greater than 1? No, it's less than 1, but we already have odd, and so we have to make sure we set odd equal true, right? So we're just going to delete the key, go to 1, delete the key, and we should be able to just return max. So here we'll delete the extra remaining code, and let's give this a shot. So it looks like we're missing an extra parentheses there, and we have to do map. Oh no, we're fine with map, it's just not in. It should be of, so it's a Python mistake. Be max plus 1. So we get 7. So let's try it. Nice. So this does make sense. And so we just kind of keep iterating while the map still has items in it. And then once we have our odd items, and we just toss the ones that are no longer needed. Time complexity of this would be, we're going to be iterating over the map many times, but at best the map will have 26 indices in it, and so I would say the number of operations we actually do I would say would be tied to the actual max length of the how many operations would we do? We're iterating while the map has elements in it. The max keys that we can have is 26. And so the number of operations we perform is really the going to be tied to the number of pairs or the longest length we can actually make. I guess in the worst case, that would be of size n, which would be the length of the string. So maybe our runtime in the worst case would be linear time, where n is the length of the string, but also n is the longest palindrome we can make. And the space would be constant space, because for any arbitrarily large string, we'll only use 26 indices, because the input is limited to lowercase and uppercase English letters. So we can definitely make this shorter somehow, so let's check. And C is a unique center. After we build our palindrome, it consists of as many partnered letters as possible, plus a unique center if possible. This motivates a greedy approach. For each letter, say it occurs V times, that we have V divided by 2 times, that's what we did, V divided by 2 times 2 letters that can be partnered for sure. For example, if we have AAAA, then we can have AAA partnered, which is 5 divided by 2, right? Floored, which would be 2 times 2 equals 4 letters partnered. At the end, if there was any V mod 2 equals 1, then that letter could have been a unique center, right? So we're checking if it's less than 1 here, but we could just check if value mod 2 equals 1 or does not equal 0. To perform this check, we would check for V mod 2 equals 1 and AND's mod 2 equals 0. The latter meaning we haven't yet added a unique character to the answer. So we do AND's plus equals V mod 2 times 2. And they're iterating while the map has values as well. So if AND's mod 2 equals 2 and V mod 2, I see. So you don't actually have to know which letter you're using as the final letter, because if the value, if the string itself dot length mod 2 doesn't equal 1, then you can just add 1 to it. So to test, you could just remove this and we'll just ignore keys of odd length, and then we could say max plus equal if s dot length mod 2 equals, it's not equals 0, then we'll add 1, otherwise we'll add 0. So let's see if that works. So s dot length mod 2, this actually doesn't work. So you could have A, B, C, D, E, F, and you have a length of 6, but they actually wouldn't be the same. That doesn't actually exactly work. They're saying if AND's mod 2 equals 0, so if our answer is currently even and our value mod 2 equals 1, then we'll add 1. But I think the way we're doing it was fine. There's likely a better way to compress it. So interesting. they're saying that as long as your answer is less than the length of the string, which would be true if you had A, B, C, A, right? The longest we could make would be A, B, C. I mean, yeah. Longest palindrome we could do would be, if we only considered even numbers, even occurrence letters, would be 2, and if it's less than the length of the string, we could add 1 to it. So that's a good point. Let's just remove this. We can do max plus equal. If max is less than s.length, we'll add 1, otherwise we'll add 0. So that's pretty cool. So we'll count that as well, and we'll try longest substring, which we also struggled with. So given a string s, find the length of the longest substring without repeating characters. So if s equals ABC, ABC, BB, the answer is ABC with a length of 3. So ABC, ABC, BB, the answer is ABC with the length of 3. So this makes sense because the longest substring without repeating characters is ABC, and it doesn't really say which one, so that's interesting. We have BB, which would be shorter, and it would also include repeating. Here we have BB, longest substring without repeating characters is just one character. B could be any of the B's. This time we have PWW, the answer is WKE with length of 3, right? Before that last W gets added, which creates a repeating sequence. Notice that the answer must be a substring. PWK is a subsequence, not a substring. S consists of English letters, digits, symbols, and spaces. Interesting. So I'm thinking for this, the best angle for this is a sliding window pattern. And so basically we'd have a window that's always going forward, and we'd like to choose when to shrink the window. So if we had A, B, we're still good. C, A, right now we have a problem because the string character we just added has made our substring have a repeating character. So then maybe we restart, right? But then this removes the possibility that we could do BCA. So what we'd like to do is remove the characters until we run into the repeating character. And this way we could basically keep a temporary array, which should be empty, and we don't particularly know if s will always have a value. It says it won't. So if s.length equals 0, the length of the longest substring would be 0. So temp will be an array which stores the values, or our substring. And then if we know that our value is creating a duplicate, then we want to pretty much iterate and remove that value. So do that in pseudocode. We can iterate over s, right? Iterate over s and add. Oh, we want to check, right? If C in, just call it car, is in temp, right? So let's say our current array is ABC. If the car is in temp, A, which is our new potential character, is in temp. So we want to remove characters from the end until we move cars from end until we remove A, or until we remove car. So until we remove the character, so we would remove the first character, right? Then we have BCA, and we'd have B, right? Then we want to, if car and temp, remove B, right? And then here what we'll do is we'll add car to temp. So we have A, right, doesn't exist in temp, B is not in temp, C is not in temp, A is in temp. Remove all characters until A. We have BCA. We add B. Is B in temp? It is, so we remove all characters until B. So we have CA, then we add B. Then we check if C is in temp. We remove C, add C to it. Then we check if B is in temp, right? And it is, we remove all characters until we get into B. And then, boom. And then on each moment, we'll take the max of max or temp.length. So this makes sense. So let's try it once with all the examples. So we have BBB, if car and temp, it's not, so we add B. Take the max, it's going to be 1. If car and temp it is, we remove it until we find B. Then we add the characters, we have B. So I think this would keep going over and over. Our max would be 1. So we have P is not in temp, so we add it. W is not in temp, so we add it. W is in temp, so we remove all characters until W, P, and W. Add W. Is K in temp? No. So we add it. E is on temp, so we add it. Then we check if W is in temp. It is, so we iterate until W. So we find W and remove those characters. So remove W, and we'd have a max of 3. So we can do this. We have max, which would be set to negative infinity, since we basically want to always be taking the max. And if we set it equal to positive infinity, then infinity will always be the value. But if we set it to 3, then maybe our potential length is greater than 3. It's less than 3, so we never actually set it. So negative infinity is a nice balance. Do for const car of s. Say if car is in temp. So say if temp dot includes. This excludes will be done with linear time, but we can optimize it by using a set. So this is just for a simpler implementation. Then what we want to do is remove characters from end until we remove car. So we'll say while temp.length is not equal 0, temp sub 0 does not equal car, right? Then we want to remove the first element from temp, right? So if our array is ABC and we just found another B, then we'll say temp is length 3 and A does not equal B. So remove the first element, which will be A. Then we'll have BC. Say temp isn't empty. Does B equal B? It does. And so we'll have one more, right? Temp dot length does not equal 0, right? And temp sub 0 equals car, right? Then we want to remove that character. And then out here we can add the character to temp. We can do temp push car, and then max. We get the math dot max or temp dot length, we can return max. So let's try this. So it works for our first case. See if it works for the remaining ones. So that does work. So this is one way to remove an element from. This part could be cleaner, and we could optimize this with a set. So to optimize this with the set to get constant lookup time, do const set equals new set, and we could say if set.has the character, or they're going to remove characters from temp and the set, right? So set.delete temp sub 0, right? And set.delete temp sub 0, and then we can do set.add car. So we're getting the wrong answer for this. So we're returning one off. Oh, well, we want to do these in a different order. So we want to remove the element at the first index, but before we remove it from temp, which is in the array. This one is actually a little slower. Wonder why that is. And I wonder if we can always assume if temp.length not equals 0, then we want to do one more. So we can. So that makes sense. Let's see how they went for it. So they also did sliding window. Using a set to tell if a character exists or not, we can define a mapping of the characters to its index. Then we can skip the characters immediately when we found a repeated character. The reason is that if S sub j has a duplicate in the range I sub j, the index j prime, we don't need to increase I little by little. We can skip all elements in the range I to j sub prime, let I to be j prime plus 1 directly. So that iterating j equals 0, I equals 0, and they're both less than n. The map contains the key for s.car at j, then I equals the max of map.get is that car at j. So it looks like this version just uses a map to remove the inner while loop. So I'll take that. So 22 minutes left. Could try three sum. So 3 sum, given an integer array nums, return all the triplets, nums sub I, nums sub j, nums sub k, such that I does not equal j, I does not equal k, and j does not equal, so none of the indexes are the same. Indexes cannot be the same. And num sub I plus j plus k equals 0. Notice that the solution set must not contain duplicate triplets. So I think what they're saying is that if the target number, there's no target number. Oh, return all the triplets such that I plus j plus k equals 0. Notice that the solution must not contain duplicate triplets. So example 1, they want us to return the array of numbers such that it sums up to up to 0. I, 0, 1. Num sub 0 plus num sub I plus num sub I. This must be a typo. Num sub 0 is -1 plus 0 plus num sub 2, which is 1, equals 0. 1 plus 2 plus 4 also gives us 0. Our distinct triplets, -0 and 1, -1, 2. Notice that the order of the output and the order of the triplets does not matter. The only possible triplet does not sum up to 0. The only possible triplet sums up to 0. There's always at least 3 elements in the array. So interesting. So the first thing I'm thinking is that we could brute force this with a 3-tiered for loop, and we would just have an inner if statement that would be if I does not equal j and j does not equal k and k does not equal I, then we would add them all together and see if they add up to 0. That would be the brute force approach in n cubed time. But can we do better? I'm thinking maybe we could do better with some sort of distance function. Maybe if we have a number I, maybe if we have a number -1, for example, we could have a map, and what we could do is we could take the absolute value of that number and 0, which would be 1. And so the number required to get that value to 0 would be 1. We could check if that was in the array, and then again we could check again for the absolute value of 0 minus 0, and we could check if that value is in the map. I meant map. If that value is in the map, the absolute value, and if it is, then maybe our distinct triplet would be that value. So if we test that out, we would have -1, right? And let's just say we assume we have a map that has all these values in it, and we said -1. The absolute value of -1 and 0 is going to be +1. So does +1 exist in the map? It does. So now we can check if so now we have 1, right? We want to take the absolute value of 1 and 0. We could check if that exists in the map. It would be -1. It does. So we do have a possible triplet. And then we could do that for every number in the map, and it should be linear time. But we also have a problem because there are multiple values that map to the same number. So we have -1, and if we were to look that number up in the map, we'd have 2 options. maybe that's okay. We could probably handle that since it might not affect the distinct triplets. We could do this in linear time if we loaded it into a map. And this map would have a mapping of basically the number. It would basically have a mapping of the number to the indice. So we know that -1 exists at both indice 0 and indice 4. So here we create a map of number to indices where it exists, right? Then we can iterate over nums, right? As we iterate over nums, we'll basically, for each number, we'll do a couple of nested operations. So we would say we'd have the number, and let's just try and jump into it and see if we can get it going. Iterate over nums. So a map. Oh, we want to iterate over the nums. Iterate over nums, and if we iterate over nums, then we want to make sure that we would have a number. Here we would try to complement for num, and if we calculate the complement for the number, we have to check if we'll calculate complement 1. If complement 1 in map, right, we want to calc complement 2. Now if we calc complement 2, we want to say if complement 2 in map, then we have right now all the things to start with. But the nature of the multiple indices makes me think that maybe we should have a stack so we can process all the potential complements or the potential indices for complement. So we push -1 onto the stack, try and find a complement for it. We find 1, right? So we're at this one, try to find a complement for 1, and we get 0. Well, let's try it for multiple. So we have -1, try to find a complement for it, and we end up with multiple indices. Multiple indices. So we check if the complement is in the map, and the index for the complement is this is a troublesome one because we could have multiple -1s, but maybe that doesn't matter because it wouldn't be distinct. So there's a deduping process at the end. We need a way to handle, so our problem right now, we need a way to handle multiple indices, but we're low on time, so we should just jump into it, grab it. And since we couldn't figure this version out, let's try a 3-tiered brute force solution. So we'd say 4 i's equals 0 i's, that's the nums dot length I plus plus. Duplicate this twice, shove it over, and we could do I, j, and k. And then we could have k here as, j here as well. And then we could have them inside. And so we'll want to make sure maybe up here, actually in here, you could make sure, right, that I does not equal j, and I does not equal k, and j does not equal k, right? Then what we can do is we can say triplets is going to be an array, right? And if this is true, then we want to check if they all sum up to 0. So we'd say nums sub I plus nums sub j plus nums sub k equals 0. Then we'd be interested in what's happening here. So we'd say triplets push nums sub I nums sub j nums sub k. I think that would be what we'd need just for a brute force solution, and then we'd probably have to we'd need a deduplication process. So our output is going to be massive, but that's fine. So now we'll have a dedupe process, which will use a set, which is going to be a new set, and the way we'll actually do this deduping process is this way. So when we push it onto triplets, we will actually keep we'll actually do it like this, where we'll actually keep a reference to the specific indices used, and it'll be I, J, and K. And the way this will work is that we'll have this distinct, which is what will actually return, which will be the distinct triplets, and we'll say for const tuple of triplets, right? The first index is going to be the actual sum, and the second index is going to be the set value. And so what we'll do is we'll say indices equals tuple sub 1 dot sort ABC into A minus B minus C. We'll say if and then from here we'll join them all as a string, and we'll say if set dot has indices, right? Then we don't want to do anything, right? But if the set has the indices, we don't want to do anything. But if the set doesn't have the indices, then it's going to distinct dot push tuple sub 0, right? And then do set dot add indices, and then we can still, now we can return distinct. Push. Oh, so we actually have to do, it's a little convoluted, but it's going to be an array of 2 arrays. So that's what we had to fix. So we actually don't need this last extra one. Oh no, this pushes them together. Oh no, it doesn't. We'll have this group and then this array, and they're all wrapped up and overlapping. So our output is still massive. So basically we're going to do tuple.sort, and actually sort doesn't return anything. It's in place, so say tuple sub1 join equals const indices. And if the set has the indices, then doesn't have it, we'll push it. So let's see what's going on with the set here. Or actually, I'm curious to see if what we're calculating with the indices it's working, and I'll also print the tuple, see if we're getting what we're looking for. So our tuple does sum to 1, it's made with these indexes 0, 1, and 2. And so when we create indices, we are joining them but they're still not being sorted correctly. So how would you sort 3 different values? Oh, you'd sort it like a regular array, actually. You have A, B, C. It's just an array that we want to sort in ascending order. So you have -1, 0, 1, which is 1, 2, 4, which is 4, 1, 2. So it actually looks like a better way to do it would have just to actually kept it as is and sorted by the array of tuples. I mean the array of all 3 values. And so it wouldn't really be a tuple, it'd be a triple. Const triple of triplets. Say triple, which would actually just be an array. We'd sort it in ascending order, and the key would just be joining the 3 into 1, and using that as a key. Maybe this takes too long. So our time limit is exceeded when our numbers are large enough. So what is our operation that's taking the longest? I wonder if it's up here, which is n cubed. But sorting this many triplets could take a long time. Is there a faster way to key them? Yes, I think there is. If we add all possible combinations instead of sorting them, then we can do that. So if we know that the sum equals 3, then we can actually do this while we're iterating through. And we can actually return triplets if we know it equals 0, right, and we know that no three of the different combinations actually gives call it not in set, and what we could say is it could be basically right, we could check if I subject I, so if it equals 0, right, and in the set does not have I, J, and K, right, then we can push it on, and then what we'll do is for the set, we'll add all possible permutations of 3 into the set. So to do that, you could do a triple for loop, or I, K, J, I, or we could just write it out. We could do set dot add, and this could be compressed with a for loop. So this would be dot add I J and K, and the different versions would be 3 factorial, which would be 3 times 2 times 1, which would be 6. So we need 5 more. We have I, K, J. We have J, I, J, I, K, J, J, K, I, K, K, I, J, K, and K, J, I. Oops, messed up a character. I, K, J, J, I, K, J, K, I, K, I, J, K, J, I, J, I, K, J, K, I, K, J, and I, J, K. Ooh. So you'd have so we're returning, but the set should, so I, J, K, I, K, J, J, I, K, J, K, I, K, I, J, K, J, I. So the set should have this value. So negative 0, 1, negative 0. Oh, even then, they're not talking about the indices, they're talking about the actual values. So I think what I should really be doing is num set I, num set J, num set K, and this is clearly not the, this is definitely not the best way to do it, but it is one way. It's just a brute force solution. We have K, I, J, and we would start them all off with the value, and then we're going to swap the different versions. And so this bottom one would be j. We'd have j I k and j k I. So ijk, ikj, kij, kji, jik, jki. And we want to check if the set has these indices. So if the set has num sub I, num sub j, num sub k. So if this solution works, I probably should have removed the console.log. But maybe this version is a little faster. So what if we remove the console.log? So it's taking too long. I'm thinking this cubic loop with the set is the minor optimization with the set, but this cubic loop is a lot. Cubic loop. Thinking maybe there's a version with a three-pointer approach. We could have maybe our third pointer sit in the center. If our third pointer sits in the center, we could check if they all sum to 0, and if they do, that'd be a valid triplet. And then from there, if we did that, so they want us to return the indices, which means they don't want us to sort our answer. No, they want us to return the triplet, so we can sort our answer. If we sorted it, that would be pretty good, because then we could pretty much sort out all impossible numbers. So if we look at the input, how do we know if a number is impossible? If we were to sort the array, so if we sorted it, then we could have maybe everything set up, right? But if we sorted it, we could be like this, and then we could know that there's no possible way, right? If this number is greater so basically we have a negative number. So basically if we have a large number like 233, we know that if we add, even if we subtract 64, 2, and 1, we know that 233 will never get to 0. So you could sort out or pretty much remove impossible numbers. Now in the same vein, if we have going up to a negative values, we have like negative 400, negative 200, negative 5, and then 0. There's no way to know going from negative. Actually, we could do it in two passes, one going from the other direction. And we'd know that if negative 5 this number is less than the sum so far, then there's no way that we can get it down